Hi, I am Alexandra Depew. I was the circuit rider for the Pollution Prevention Institute the previous summer, and I'm a current KU senior. My locations, I worked at 8 different facilities, mostly obviously on the eastern side of Kansas. The industries ranged from many different kinds of manufacturing to meat processing to an aerospace system facility. The project areas that they all fell under were energy, water, and material, with the breakdown shown below. So for the first facility, it was an agriculture equipment manufacturing. They just brought me in for a compressed air audit, and I found 32 leaks, annual savings of 7.8 thousand, with a kilowatt hour reduction of 166,000. Now, the compressed air audits are a very easy first step in the door when working with these companies, because they do get these larger savings for a very short amount of time. The whole compressed air audit took under 3 hours, including introductions at the facility and transportation between buildings. The compressed air audits, obviously they save wasted energy from pumping the compressed air, and if there are other gas lines, it can save gases such as welding gases, which tend to be very expensive. A benefit that many of the facilities did not take into account when doing the audit is there is an additional employee safety through reduced noise levels and potential injury from coming into contact with compressed air. The next style facility was greeting cards manufacturing. For the first one, I completed another compressed air audit. This one did take about 6 hours through the whole 3 stories of the facility, with 59 leaks, annual savings of over $15,000, and a kilowatt reduction of just under 450,000. For this project, it was noted that, and it's pictured, both pictures are at the same junction of one of their attachments, that there was a leak at every single station in this facility that had that style attachment. That is why there were so many leaks, and it was more of alerting the facility that this would be a continual problem and for them to easily fix it at each location to save them $15,000 annually. As a second project for this specific facility, they wanted me to look at the efficiency of their cooling water towers. This was done through research, conversations with the operator and their specialist. It was actually found that their cooling water towers already employ the specialist that monitors the conductivity levels and utilizes the sock filter. And so without fully replacing the water towers, there was no way to get a noticeable increase in efficiency. So replacing the water towers was the only solution to see the efficiency growth that they wanted, but it was not feasible for the costs. The second greeting card manufacturing facility, also I did a compressed air audit, a very similar size facility with 56 leaks, annual savings of over 14,000, and a kilowatt reduction of over 400,000. The difference at the end of this discussion with the facility was a maintenance worker came in to the conversation to ask what system I had been using. And we use the UE system that is pictured below. He had been familiar with it, had seen it before, and was actually curious about his facility purchasing the equipment to be able to further reduce the number of leaks each year. Through conversation, it was actually recommended that the facility purchase the equipment, as the return on investment would be within 6 months for the current system that I had been utilizing. And with the maintenance already enthusiastic about implementing that preventative maintenance measure, it was a very highly recommended solution. For this facility, I also did a lighting survey that was already a project in progress, and they wanted to know if they were to complete the project instantaneously, what would their savings be? They had currently been employing the principle of when it burns out, replace it with an LED. And so, as noted, the findings, there were still over 4,000 fluorescent bulbs in use. And so to replace those all with LEDs, they would have an annual savings of just under 16,000 and a kilowatt reduction of over 450,000. As many of you know, switching from fluorescent to LEDs improves brightness, reduces wattage, and reduces cost due to the decrease in wattage. Again, this was a recommended project. So I visited 3 steel manufacturing facilities during my time with PPI. At the first one, There was 16 leaks, an annual savings of 4,000, and a kilowatt hour reduction of over 130,000. At this specific facility, they were also interested in their use of a blowdown technique. Due to the size of the facility, they did not currently have a dryer on their compressed air line to remove moisture. They had been opening the blowdowns when the lines were in use for welding and wanted to know how much that was actually costing them and if it was more efficient to switch to an actual dryer. Their current technique was satisfactory for the results that they were getting. I did find that the annual savings was under $2,000 with a kilowatt hour reduction of just under 40,000. Due to the cost of a dryer for the whole compressed air line, it was not a feasible solution. Individual desiccators would have a return on investment for the few lines that they actually utilize the blowdown alternative with a return on investment of under a year. But I wanted them to do more, or it was recommended that they would do more research to ensure that the type of desiccator they chose would fit with the system that they currently employed. For a long-term solution, it was recommended that when a compressor eventually goes down, to investigate buying a compressor and dryer combination product, as that decreased the cost considerably. At the second steel manufacturing facility, the main project was in their paint gun efficiency. They were reaching the permit levels of their xylene emissions due to their paint usage. Through conversations, it was discovered that the only possible solutions were changing the paint type, changing the number of coats, or changing their application. Again, through discussion, it was found that they really can't change the paint type as it is a standard for the industry, and there's many issues concerning durability if the paint was switched to something with less xylene. As for the number of coats, as the color was darker, they had to use less coats, but as the clients typically chose the color, they did not have much say in the shade of the color. So that was also deemed not feasible. That left with changing the application style. The facility utilized just standard pressure paint guns. Switching to an industry standard high volume, low pressure paint gun would increase the application efficiency by 15%. That annual reduction was over 5,000 pounds of xylene. That would drop them way below their permit levels with no concern about passing it, and save them an annual amount of $43,000 due to a decrease in paint usage. I should note that within discussing with the facility that it was already determined that they had proper training and application of paint and their systems were well maintained. So it was found that those two were not areas of improvement. As a final project at that facility, a solvent reclamation project was re-examined. They had had a previous circuit rider intern recommend that they use a solvent reclamation equipment as they did not employ any reclamation. And as the facility actually increased their solvent usage throughout the time since the previous intern had been there, it was an increased savings to $11,000 per year with an annual reduction of 495 gallons of the acetate. After my site visit and following up with that facility, they were already looking into that solvent reclamation system almost immediately after I left due to the large amounts of savings, both in costs and their VOC emissions. At the final steel manufacturing facility, the main project was a lighting survey, but I did complete a compressed air audit that took about 15 minutes due to the very small nature of the facility, finding 9 leaks, only an annual savings of $600, kilowatt reduction of over 13,000. There was not much more to say as the facility already utilized very good maintenance prevention in their welding gas line leakage due to previously being notified about the potential for leaks. The biggest project was a lighting survey where they were converting all of their fluorescents and metal-eyed halogens to LEDs. They had already been beginning the process and experimenting with how many panels of LEDs they could, or of fluorescents they could replace with one LED, which is what I have shown at the bottom of the screen. They were able to say that 4 4x8s were able to be replaced with only one 2x2 LED panel. And I did verify this using lighting readings throughout the whole facility. And so using the optimum level of the lighting conversion, along with their already choice of lighting styles, the annual savings to complete the project would be just over $3,000 each year, with a kilowatt reduction of 69,000. The most shocking aspect that the facility did not anticipate was that their current metal halide levels in their bay areas did not actually meet OSHA lighting standards for that facility type. They had already replaced a certain section with the LEDs, and so I was able to go in there with the light meter and verify that with the updated lighting, they were able to meet those lighting standards, but their status quo did not meet lighting standards. So that was an added benefit that also pushed for this project to be completed in a more timely manner. I did visit an aerospace systems facility with two main projects, the first one being their water treatment system. It was a state-of-the-art, only 4 years old system that should have had a recycle ratio of 50%, but upon conversations with the operators, they were only achieving a 10% recycle ratio due to having to constantly restart the system because, and it was found out that the operators never received the promised 2 full days of training on the system. They were left with only 15 minutes due to complications during installation. An example of this is they did not know how to or when to replace the carbon filter, and it had been over 3 years until it was replaced, when it is noted in the manual that it should have been 6 months to 1 year. So every time that the water treatment levels were not satisfactory, or they noticed something off, something had gotten through, they had to restart and flush their whole system, which led to the very low recycle ratio. With proper operator training that would also increase the operator's safety within the system, they could decrease their water costs for an annual savings of over $30,000, annual water reduction of 460,000 gallons of water. The company had already quoted a few different companies for operator training and had those numbers for me already, but the higher ups believed that the return on investment was not reasonable. With showing how much the increase of 40% recycle ratio would actually save them, the return on investment for most of the quotes was under 6 months, which made it much more highly recommended, feasible, and all around a very good project to implement. The second project at that aerospace systems was in their filter cake disposal. All of the filter cakes had to be treated as hazardous waste. And so once to 2 times a day, they would scrape off the filter cakes, put them in boxes, and mark that as hazardous waste. Again, through conversations with the operators, it was noticed that when the moisture content was able to be 10%, it was much easier to remove for the operators, and so they would have to spend less time on it. It wouldn't upset them so much, as it would not be as hard of a task. The current moisture levels on the day that I visited was approximately 30%. So reducing the moisture content would make their operators happy, but it would also reduce their hazardous waste costs, as that 20% reduction of water would save them over $7,500, as they would have to dispose of less 30,700 gallons of hazardous waste. The solution for this was actually determined to be preventative maintenance on the pump, as the increased drying time and increased moisture content was due to the incorrect pressure that pump was pumping water at the filters. So again, that preventative maintenance, the cost for that was remarkably low, so the return on investment was almost instantaneously. The final facility was a meat processing plant. The largest new project that they wanted me to investigate was in reducing their clean water nozzle sizes from 3/4 to 3/8 of an inch. They have an outside cleaning crew that would remove the reduced nozzles whenever they would come to clean. And so they wanted to fix the reduced nozzles so that they couldn't be removed, but they wanted data and reasoning to back it up. With the 3/8 nozzle, it should increase the cleaning efficiency as it's a higher pressure. It should reduce the water used, and it should help standardize the cleaning among each cleaning crew member, as a majority, but not necessarily all, always remove the nozzle sizes. Through my calculations, and that the cleaning water was highly pressurized in the system and heated, permanently reducing the nozzle size would save just under $100,000 each year, and a reduction of over 24 million gallons of water, and a reduce of over 8 billion BTU of natural gas. It was a highly recommended project that our contacts were happy to receive the numbers for, to support their decision to permanently attach the nozzles. Another project was a LED conversion. This facility had a full-time intern previously, and I was reinvestigating how they had done the LED conversions, and found that they hadn't implemented most of the recommendation. And I also found that if they did recommend or complete the implementation of the rest of the recommended project, which was found to still be viable numbers, it would annual savings of over $20,000 and a kilowatt hour reduction of 280,000. It was highly recommended that they re-examine the feasibility of this project and implement it. I also did a very quick compressed air audit. We found 17 leaks, annual savings of over $12,000 with a kilowatt hour reduction of over 170,000. It was recommended also that they continue to investigate for compressed air leaks. It was hard for me to find all of them because they did not turn off any machinery or anything when I was around the project. So I was not able to catch all the compressed air leaks. Also, it was only limited to about an hour of investigation, while a facility that time was deserving of 6 to 8 hours. So the findings there are only a fraction of what that facility could potentially receive. Now, the final projects for the meat processing facility, again, these are both from a previous intern's report. There was a urinal trough in the men's bathroom that had a continuous flow of water. The facility had implemented a timer, but upon the day of the site visit, it was found that somebody had bypassed that timer and nobody knew for how long. So the solution that we came to while I was there was that they would permanently lock so that the timer, so that it could not be bypassed without the key. Implementing that locking, which they had the tools on site to do, would save them over $5,500 and a reduction of just under 2.5 million gallons of water. The final project was on their multi-back packaging system. They had had a partial implementation, but had gone with a closed loop system instead of the timer system recommended by the intern. This was due to a more consistent quality, even though the closed loop system was more expensive. If they were to complete the implementation of their closed loop systems, they would save an annual $5,400 and a reduction of just under 2.5 gallons of water. The return on investment for the multi-back packaging system is a lot larger than many of the other projects, but again, with conversations with this facility, the reduction of their water usage was a very high priority, and they looked beyond the economic benefits and more into the societal impact of their facility. So in summary, out of all of the 8 facilities and all those projects, it was just under $300,000 of savings if all of the recommended projects were implemented, over 2 million kilowatt hour reductions, over 28 million gallons of water reduced, over 30,000 gallons of hazardous waste avoided, for a total of just under 2.9 thousand metric tons of CO2 equivalent as the greenhouse gas reduction.